Hey everyone, welcome to Homeschool and welcome back to Physics series, and I am with class 11 chapter 3, that is motion in straight line. In my previous class we have already covered the average speed, average velocity, distance displacement and few important questions on that concept, right? And in today's class we will talk about very important concept, that is acceleration. And remember, my approach towards the concepts is very different. See, my approach towards the concept will help you to understand the concept in the easiest way and can give you confidence to solve the problems for competitive examination. So my main focus of explaining all concepts are towards the competitive examination. Okay, so definitely these videos are helpful for you. It can give 100% benefit only if you can watch the video till the end. And at the end, I will be solving few questions from previous NEET question papers or JEE question papers. So don't miss, watch the video till the end and get maximum benefit. Let's enjoy the concept of acceleration, right? So acceleration is not a new word for us. You know what we say, accelerating the car means more acceleration, with more speed it goes, isn't it? So what actually we mean by acceleration? So acceleration is nothing but, velocity, right? So our velocity is displacement by time. Acceleration is rate of change of velocity with respect to time. Okay, so this is how we define acceleration, but I can tell you practically what exactly we mean by acceleration, right? So first let me define this. It is nothing but rate of change of velocity with time is called acceleration. So we can derive an equation for acceleration. Okay, say suppose if this is a ball and if it is moving with some velocity, let that velocity be initial velocity u. Okay, so u is what here? Let me consider u as initial velocity. In your books, they will consider u naught or v naught as initial velocity, but let me consider u as initial velocity. Okay, to understand the concept in a easiest way. Fine. And with u, the ball is moving with a velocity and it is reaching the final point here. Okay, so this is the start and this is the end. So here the ball has stopped with final velocity v. Okay, so here the moment ball has reached from this point to this point, say at this point the velocity is not same as u. The velocity has changed. That changed velocity, let it be v. Okay, so I will call v as final velocity. So what is v? Final velocity, right? And in your books you will have final velocity as v or u, right? Okay, so I am here considering u as initial velocity and v as final velocity. Okay, and this change in position of a ball from here to here took place in t seconds. So time for this change is t seconds. Okay, and here what is acceleration? A. Acceleration is normally denoted with the letter small a. So what is your acceleration? So here acceleration A is equal to change in velocity. How do you write change in velocity? Final velocity minus initial velocity, isn't it? So what I can write? V minus u divided by time, right? So our acceleration definition itself, velocity, change in velocity by time. Change in velocity. So change in velocity is final velocity minus initial velocity. So v minus u by t, right? So this is what our acceleration. So one more equation I will derive from this. At at is equal to v minus u. So what is v? If I have to calculate the final velocity of a ball, I can always calculate like this. V is equal to u plus at, right? So this is one of the very, very important equation. Okay, so this and this, yes, both are talking about the same thing, and this is called Galileo's first equation of motion. First equation for uniform motion. This is one of the very, very important equation that you have to remember. Clear? Fine. And now, okay, so this is how we understand what actually we mean by acceleration. So it's nothing but change in velocity divided by time. And I can practically bring you the feel of understanding the acceleration. Okay, so acceleration is nothing but you are adding velocities. Say for example, you see a ball, initially it has a speed or it has a velocity of 2 meter per second. Okay, and now it has moved to this point in 1 second. So in 1 second the ball moved from this position to this position. Okay, so imagine if I have acceleration 2 meter per second square. What does this mean? Can you tell me what is the velocity of the ball at this point? It is initial velocity. It has 2 meter per second velocity plus you are adding 2 meters per second. Okay, so 2 plus 2 in 1 second, right? So this is the velocity of the ball at this point. Again from here the ball has moved little further, 1 second, right? So what is the velocity of ball at this position? It is initial velocity plus 2 plus 2, right? So what I can write? It is 2 plus 2 plus 2. Say you are actually adding velocity for every second, right? So initial velocity of a ball was 2 meter per second. The moment it moved here in 1 second, say acceleration 2 meter per second means what? To the initial velocity, extra velocity it has gained. Again from here to here, in 1 second when it has moved, 2 plus 2 plus 2, right? Again from here to here in 1 second when it has moved, 2 plus 2 plus 2 plus 2, right? So that's what we mean by acceleration. Say acceleration means what? Velocity, the speed is getting more and more, right? As the ball moved from one place to another place, right? Initially the speed was here, but from here to here in 1 second, the speed increased, right? And from here to here, the speed again increased. From here to here, the velocity or speed again increased, right? So this adding up of velocity itself, we will call it as acceleration, right? So practically this is what the meaning of acceleration, right? And now, okay, we got to know the equation for acceleration. So this is just to make you understand about acceleration, I told this. Otherwise, this is what the equation you have to remember for acceleration. Questions can be asked on this. So let us solve a few simple questions. Okay, say why? Because all these factors, this V, U and A has signs. Okay, so you have to indicate with certain signs. While solving a problem, you have to take proper signs for V, U and A. They have directions. Okay, so their direction is represented with the help of signs. Okay, so you will talk about the direction with the help of signs. So you have to definitely consider signs when you take these things for the calculation. Okay, so let's talk about the signs of these factors, that is final velocity, initial velocity and acceleration. Then let's quickly go for some problems. See guys, here, say normally when you have x-axis and y-axis, say this is a positive x-axis. Say if you go in this direction, say you will consider it as positive direction. Okay, so when your direction is something like this, then this is considered as positive. Okay, so if the acceleration or initial velocity or final velocity, if it is there in this direction, it's always considered as positive. and this direction is always considered as negative. Okay, and if it is moving upward direction, it's considered as positive, and moving downward direction, it's considered as negative. Okay, so this is the general sign convention you have to remember, guys. So you will understand this better when I go for a problem. So just observe this example. See, I have a problem. Instead of telling you in a sentence, I'm just telling a problem in the form of diagram. Okay, say for a physics problems, drawing a diagram is very, very important. If you can draw a correct diagram, half of the problem is over. Okay, say you have a ball with a velocity 3 meter per second. Okay, and it has an acceleration 6 meter per second square, and the time to reach from this point to this point is 2 seconds. And what you have to calculate is, you have to calculate v, that is the final velocity. Okay, say here how do you calculate? What is the sign you will take for u? What is the value of u they have given? Initial velocity they have given us 3 meter per second. Say ball is moving from here to here. Say ball is moving something like this, right? So always I consider, if it is moving like this, I consider it as positive. Okay, always fix. Or you can consider this direction also positive. It's your wish. Okay, but when you consider this direction as positive, everything must be there in that direction. Okay, so according to a direction, you have to consider the sign. Say this direction I considered as positive, isn't it? So u, initial velocity, ball is moving in this direction, so u is positive. And what is acceleration? Yes, ball is moving from here to here, right? So your a is also plus. So this is also plus 6 meter per second square. So you have to calculate v. So how do you calculate v? So we have a formula, v is equal to u plus at, right? So u is how much? 3 plus acceleration is how much? 6 into time is 2 seconds. So it is 3 plus 6 2s are 12, right? So 12 plus 3, that is 15 meter per second is your v value. So this is how you have to apply science. Clear? So now coming to this example. Observe this example, guys. So it's really very important. Here what you have to calculate is, u is given. Say a ball has started its journey here at the velocity 8 meter per second. It has moved and it's coming backwards. It's coming backwards. And you observe the final velocity 5 meter per second. Okay, 5 meter per second. So initial velocity was greater, final velocity is lesser. That means your acceleration is decreasing. I told you acceleration means what? The velocity gets added up, right? So initial velocity is less, final velocity is more normally, because the acceleration is something that is getting added up. But here the acceleration is decreasing, that you can observe, because final velocity is much lesser than initial velocity. Okay, and you see the ball is moving this way, in this direction. Okay, say here you actually have to calculate a. You should calculate a. Okay, say now what is u value? U is equal to, say u is plus 8 meter per second only, because initially the ball is actually moving in this direction. So I am considering this direction as positive. Okay, so but now what is v? V is what? You see the ball has reached here, again from here it took a U-turn, right? It took a U-turn and it's coming in this direction. So if it is going in this direction, it is negative, right? When you consider this direction as positive, this direction you will consider as negative. So u is minus 5 meter per second. Okay, so what is time? 2 seconds. So how do you calculate acceleration here? So v is equal to u plus at, right? So v minus u is equal to at. So v minus u divided by t is equal to a. So what is v? What is v? V is minus 5, right? So minus of what is u? Plus 8 only, 8 divided by time is 2 seconds, right? So what is the answer you will get? minus 5 minus 8 is actually minus 13 by 2. Right? So minus 13 by 2 is what? 1 6, right? And 6.5. Say your acceleration is minus 6.5 meter per second square. Unit, don't forget. So your acceleration is minus 6.5 meter per second square. You see, acceleration is negative. Acceleration is negative. So actually, what does this mean? You see, the acceleration is decreasing. Acceleration is decreasing. That means the object is slowing down. The object speed has become slow. Object's velocity has become slow, isn't it? So if object is slowing down, then such a acceleration is called as deceleration. Deceleration, or it is also called with the term retardation. Okay, so what is retardation? If the object is slowing down, you can observe this initial velocity 8 meters per second, but the final velocity 5 meters per second. That means the speed is getting slow. Okay, so acceleration is negative, but it doesn't mean that if the acceleration is negative, it is called as deceleration. No. Okay, so negative acceleration, this negative sign indicates that the object is moving. It took a U-turn and it is moving in the opposite direction. Okay, so negative sign for acceleration doesn't mean deceleration. Deceleration means what? Object is slowing down. Okay, so that is what we mean by retardation. So what I wanted to tell you is negative acceleration does not mean deceleration. Okay, so that negative sign will only tell you about the direction. Whereas I can say here the object is decelerating, retarding. Why? Because the speed or the velocity is getting decreased. That you can observe by comparing initial velocity and final velocity. Okay, so this is the concept of deceleration or retardation. So what do you mean by deceleration? If the object is slowing down, then the accelerations associated with that object is called as deceleration. Okay, so hope the concept is getting clear for you. And now let's go for a few more examples. See the third example, guys. I have a ball. Okay, say if this is a ball, I am throwing up and it is coming down. Okay, so you're throwing up with a velocity, with the initial velocity. This is actually initial velocity 15 meter per second. So with the initial velocity 15 meter per second, I have thrown up and it has come down. It has come down. Okay, it has reached the ground. It has reached the ground. And what you have to calculate is final velocity you have to calculate. Okay, so and here this particular change occurred in 5 seconds. And you see here, ball went up and it is coming down, right? So what is the acceleration here? You have to consider acceleration due to gravity. So what do you mean by this G? This G is nothing but acceleration due to gravity. Due to gravity. Okay, say anything that is coming from top and if it is reaching a ground, you know, it will have an acceleration this much. Okay, it's actually the actual value of G is 9.8 meter per second square, but most of the times we can consider this value for easy calculation. Okay, so acceleration here is this much, right? So what you have to calculate? V, the final velocity you have to calculate. With what velocity the ball is hitting a ground, that's what you need to calculate. Okay, so here say what is the equation? V is equal to U plus AT, right? So what is U? If I consider this direction as positive, here signs are very, very important. Say always I consider this direction as positive and this direction as positive, right? So here U, initial velocity, ball is moving up initially, right? So U value is positive only. That is U is equal to plus 15 meter per second. What about the G? What is the sign I consider for G? So G is what? Acceleration due to gravity. See, when a ball from top, from here, if it's coming bottom, its acceleration is this much. See, the ball is moving in this direction. That is in the negative direction. So G value you have to consider. This is like acceleration. So your acceleration, that is G, A is nothing but G, is minus 10 meter per second. Understood why we considered negative sign here? Because the ball is moving in the opposite direction. We considered upward direction as positive, no? So if this is positive, then downward direction is negative. So that's why this is the acceleration due to gravity. Acceleration for downward direction. So minus 10. So what you have to calculate? V is question mark. So substitute here. U is how much? Plus 15 plus acceleration is minus 10. Minus 10 into 5, right? Time is 5 seconds. So it is plus 15 minus 10 5 is 50. So you will get minus 35 meter per second. So this is your answer. Okay, so what is V? It is minus 35 meter per second. So what does this minus sign indicate? It indicates the direction. The ball is moving and hitting in this direction, right? We consider this direction as positive, then this direction would be negative, right? So that's why you see the direction is something like this. So you got minus sign in the answer, right? So here the sign will majorly talking about the direction in which the object is moving. Okay, so we normally consider this direction as positive and this direction as positive. The other two directions will be negative. See guys, you have an object which is moving with initial velocity u and it has reached this point with final velocity v. Okay, and let the acceleration for this object, let it be a, and this took place in a time t seconds, right? And normally, you know what, they will ask you what is displacement. Okay, so displacement you can use the letter x or yes. Okay, so this means displacement, right? So displacement symbol here is x or s. Okay, so we mainly use x normally, right? So remember, s means not distance, it means displacement in this case. Okay, say you have one beautiful method here. Normally average velocity, we all know average velocity that we studied in our previous video in a detailed way. So average velocity can be calculated with one shortcut formula, that is here in this situation when a ball is having a initial velocity u and has a final velocity v with this much acceleration and time. Okay, you can calculate average velocity with the formula v plus u by 2. V plus u divided by 2 or u plus v divided by 2. Okay, so this really works out very nicely for you to calculate the numericals. So this is how we can calculate average velocity as long as this acceleration is uniform acceleration. Okay, so this works out only for uniform acceleration. If the acceleration is uniform, that means constant. Okay, constant acceleration. This is really very important. Only if an object is moving with the same acceleration throughout, uniform acceleration, then average velocity can be calculated by the formula v plus u, that is final velocity plus initial velocity divided by 2. And now we all very well know that what is the basic formula for average velocity? It is nothing but displacement by time, right? So if you want to calculate displacement, average velocity into time will give you displacement. Say yes. So what is average velocity? Average velocity is v plus u by 2 into t will give you displacement. So this is one very important formula that you have to remember always. So displacement can be calculated with this formula. It will help you so much. Okay, so v plus u by 2, this is average velocity that you can calculate for uniformly accelerated body, multiplied with time will give you displacement. Okay, so one example, one question relating to this formula I'm showing you. See here, you have an object, it is starting its journey with 8 meter per second. Remember, always initial velocity need not be 0. Okay, it need not be 0. Only if an object is held by a hand, I mean if the object is at rest, then initial velocity can be taken as 0. But for a moving object, anywhere you can consider the point as initial velocity. Okay, so here actually it's a moving object. Say somewhere you considered as initial velocity. So that's why here object is moving with certain velocity. That is our initial velocity. So this is u value. Okay, and v value, final velocity value has not given. Acceleration is given 5 meter per second square. Time is given 4 seconds. So what you have to calculate is displacement. So for displacement, we have a formula v plus u by 2 into t. Okay, so here we have u value. What is u value? U value is equal to, okay, always think over the directions. So if this is moving in this direction, it's considered as positive. Yes, u value is plus 8 meter per second. So acceleration they have given, time is given, time is equal to 4 seconds. Say for our formula we want u value, time and v value. U value is there, t value is there, but v value is not there. So first you need to calculate v. Okay, so what is v? So how do we calculate v? We have a formula, Galileo's first equation, v is equal to u plus at. So v is equal to u is 8 meter per second plus acceleration is 5 meter into time is 4 second. So 8 plus 5 fours are, it is 20. So v is equal to 28 meter per second, right? So v is how much? Plus 28 meter per second, because the object is moving in this direction, right? So now calculate displacement. So s is equal to v plus u by 2 into t. So that is v is 28 plus u is 8 divided by 2 into time is how much? 4 seconds. So can you calculate displacement and put your answer in a comment box? So I expect the answer in a comment box. Okay, so this is one of the best way to calculate displacement, right? So remember the formula, s is equal to v plus u by 2 into t. Okay, so very, very important. Okay, so now let's go for one more formula. We have two more formulas that can help us to calculate the displacement. Okay, say if you are using this formula, we don't have a. In case in a question, if a is not given, then also we can calculate displacement, right? Say once you know u and v and time, that is enough for us to calculate displacement. Okay, say for example, if you have to include a in a formula to calculate displacement, we have other formulas. So let's study and go for the remaining two formulas which can be used to calculate displacement. See guys, observe carefully how I will derive a second equation for calculating displacement. See, you have an object which has an initial velocity u, okay, and it reached here with final velocity v, and let a be the acceleration and t be the time. Okay, say here in case if you don't know the final velocity, how do you calculate? Final velocity v is equal to u plus at, right? We know this. And we know how to calculate average velocity. Average velocity is just u plus v divided by 2, right? So u plus v, instead of v, I can put u plus at divided by 2. Okay, so this becomes 2u plus at by 2, right? Or here I can actually cancel this and this, right? I can separately write 2u by 2 plus at by 2, right? So directly I can write average velocity is equal to u plus half at, right? So average velocity is u plus half at, we can also write. And now what is displacement? Displacement is equal to average velocity into time, right? So v bar into t. So S is equal to what is v bar? U plus half at into t, right? So S is equal to ut plus half at square, right? So this is the equation we have got, right? See, this we can derive another formula for calculating displacement, that is S is equal to ut. U is initial velocity, t is time, plus half a is acceleration and t is again time square. Actually this is called as Galileo's second equation for motion. So second kinematic equation is this, okay? So of motion for a uniformly accelerated body, okay? So another equation, and let's apply this equation for a particular problem. You see this example. Here actually there is an object with initial velocity. So this is u is equal to 15 meter per second. It's moving with this much acceleration. So a is equal to 2 meter per second square. And final velocity v we don't know. And time is 3 seconds. They are asking you to calculate displacement. They are asking you to calculate what? Displacement. If this is the situation, initial velocity is there, acceleration is there, time is there, final velocity is not there, displacement they asked you. One is, the previous problem was also something like this. We have used which formula? Yes, we have used displacement is equal to average velocity into time, right? So this formula we have used. This also you can use, but you see I will use this formula here because final velocity is not given. Whenever final velocity is not given, then definitely you can use this equation. Okay, so what is S? Yes, that is S means not distance, S means displacement here. Okay, so S is equal to ut plus half at square. So what is u? U is plus, say this direction, object is moving this direction is always considered as positive. So u is positive, a is positive, v is not given only, right? So always consider signs, that's the most important thing. So u is plus 15 into time is 3, right? Plus half into a, acceleration is 2 meters, right? So 2 into t square is 3 square, right? So here 15 3s are 45 you will get, plus half into 3 square is 9. So 9 2s are 18, right? So this is 1s are and 2 9s are 18. So 45 plus 9, how much guys? So displacement is 54 meters, right? So 54 meters is your answer. So this is how you can apply this formula. So whenever final velocity is not given, you have initial velocity, acceleration and time, then definitely you can use S is equal to ut plus half at square. Fine. So this is one formula to calculate displacement. Second formula to calculate displacement. We have the third formula to calculate the displacement, that is called as Galileo's third equation for motion. So let's understand that third equation. See guys, observe carefully how I derive third equation to calculate the displacement. See, we have our basic formula V is equal to U plus AT, right? So can I write this as V minus U is equal to AT? And again, V minus U by T is equal to A, right? So this is one equation I got. Let me call this equation as equation 1. Okay. final velocity minus initial velocity by t is equal to a. Fine. And now we have a formula for displacement. So displacement is equal to average velocity into time, right? So what is average velocity? V plus u by 2 into t. So let me call it as this as equation 2. Multiplying equation 1 and 2, what do you get? So when you multiply 1 and 2, what you can write? So let me write this equation this way. Okay. So let me v plus u by 2 into t is equal to yes. Okay. So multiply this with this with this. So when you multiply this with this, say in the denominator you had t and this t gets cancelled, right? So and when you multiply, we will actually get v square minus u square by 2 is equal to as. So generally we can write it as v square minus u square is equal to 2as. So what is v? Final velocity. What is u? Initial velocity. A acceleration, S is displacement, right? Say this equation we will call it as Galileo's third equation. Galileo's third equation for uniformly accelerated body. Okay, so using this also we can calculate displacement. Let's see how. Just see this question. You have an object which is moving with initial velocity 5 meter per second. This is u. Okay, and it's moving and it's coming backward. It took a U-turn and it came backward, and see the final velocity 7 meters per second. And its acceleration, this is acceleration, a is equal to 3 meter per second square. Okay, say you have to calculate displacement here. Calculate what? Calculate yes, that is displacement. Say here, this formula you can always use. See, u is there, v is there, a is there. What else you want? V is there, u is there, a is there. Can't you calculate displacement? Yes, you can use this formula. But observe the signs. What are the signs you will take? What is the sign you will take for u? U, object initially it's moving in this direction. This direction is always considered as positive, right? So u is equal to plus 5 meter per second. What is the sign for v? It's coming backward, right? Ball is coming backward. It took a U-turn and it's coming backward, right? Say this direction, if an object is moving, then final velocity is minus 7 meter per second. And what is your acceleration? Acceleration, object is moving backwards, right? Acceleration also have to be considered as negative sign. Okay, so it is minus 3 meter per second square. So now you substitute. What is your formula? V square minus u square by 2 is equal to as, right? So s is equal to 2 into a I can write. So what is v square? Along with the sign you take, it is actually minus 7 square. This is minus 7 square. Minus u is what? Plus 5 square divided by 2 into a. A is minus 3. Right? So what do you get? 7 square minus 7 into minus 7. Right? So this would become plus. Right? Minus into minus, how much? It's plus. So 7 square is 49. Minus 5 square is 25. Divided by 2 3s are 6. That is minus 6. So you would get 24 by minus 6. Say that is equal to minus 4 meters is the answer. So how much is the displacement? How much is the displacement? How much is this displacement? It's minus 4 meters. Okay. See, when you calculate, when you use this formula, you have to be very careful. Minus, along with the sign, you take it in a bracket. Most of the students make mistakes in calculating when you consider this formula. So better go for the other formulas. Okay. So let us summarize what all the formulas that we have learned. Okay. So the very basic formula is V is equal to U plus AT. A second formula is calculating displacement v plus u by 2 into t. Whenever acceleration is not there, initial velocity is there, final velocity is there and time is there, then quickly you can use this particular formula to calculate displacement. And also displacement is equal to ut plus half at square. Whenever final velocity is missing in a question, then if they asked you to calculate distance or displacement, then this formula. And then what is the other formula? S is equal to v square minus u square by 2a. Okay, see, when you use this formula, you have to be very careful with the calculations. Okay, so instead of these two, most of the times this will work out to calculate the displacement. Calculation is also much easier. Okay, but should we remember these two? Yes, you need to remember. According to a situation, you have to use these formulas. Okay, say this is all about acceleration and the three most Galileo's equations for uniformly accelerated object or body. Okay, and now let us deal with some questions from previous year NEET papers. See guys, observe this question carefully. Very simple actually. Just draw a diagram so that you will understand what is given and what they asked you to calculate. Okay, so you have a car. So there is a car and this car from rest it is starting. Okay, it was at rest initially. So from this you understood that u, that is initial velocity of this car, is 0 meter per second. When something is at rest and it is starting, that means that particular car's velocity is 0 meter per second. So a car at rest accelerated uniformly with certain acceleration. It is moving from rest. It is moving to a certain speed and it reached some point, okay, with a speed 144 kilometer per hour. Actually, this is your final velocity. In 20 seconds, in how much time the car moved from this point to this point? It is in 20 seconds. Okay. They are asking you the distance that it has covered. Distance here nothing but displacement. So they are asking you the displacement is question mark. Okay, see what is given? Initial velocity 0. How did you come to know that it is 0? They said the car started at rest. It was at rest. Okay, from rest mode it has started. So initial velocity 0 and it reached to a certain point with this velocity. So final velocity is this much and time they have given 20 seconds and calculate displacement they said. Say diagram says everything. So you have to calculate displacement. So which all the formulas you have to calculate displacement? One is displacement is equal to v plus u by 2 into t you have. Okay, the other formula S is equal to ut plus half at square you have. And the other formula is what? S is equal to v square minus u square by 2a you have. Right? So which formula is better to use in this case? You can use any formula, no doubt, but which is better? If you have to use these formulas, you want acceleration, right? But acceleration value is not given. Acceleration value is not given. Okay. And you have initial velocity, final velocity, time. Then the best option of calculating displacement is by using this formula. Okay. So use this formula. But one problem here, V is given in kilometer per hour. Change it to meter per second. Okay. So how do you change? V is given in 144 kilometer per hour. How do you change? Change to meter per second. So V is equal to 144 into it is 1000. Okay, 1000 meters divided by hour converted into seconds, it will be 3600. See guys, when you calculate this, you will get around 40 meter per second. So your V in meter per second is 40. So now use that formula, displacement they asked you to calculate. So displacement S is equal to V plus U by 2 into T. So what is V here? 40 plus U is 0 divided by 2 into 20. Right? So here 20 into 20, that is 400 meters is your displacement. So your answer is 400 meters. Right? So everything is there in understanding a question and then drawing a diagram. So draw diagram. This is very, very important in physics. Always, if you can draw a correct diagram, half of the problem is over. Okay, so always draw a diagram and then try to think of which concept to use. Okay, so which formula to use. So use a suitable formula and solve the problem. Let's go for one more question now. Coming to second question, guys. Try to understand the question carefully. A ball is thrown vertically upwards. Okay, say from ground, maybe this is a ground. So from here, the ball is thrown vertically upwards. When it reaches half the maximum height, okay, let this be the final point the ball has reached. Okay, let this much be the height h. Okay, ball was in a ground. From here, I have thrown up and it is the final point, and let the height, the distance between this and this be h. You see here, when it reaches half the maximum height, I mean when the ball has reached this position, its speed is, I mean at this point, the speed, that is the velocity, is 10 meter per second. Find the maximum height attained by the ball. So they are actually asking h is equal to question mark. Okay, maximum. What is the height between the ball which is there on ground and the ball which is there in air somewhere here? Okay, so this height they are asking. But what they have given, as the ball moved half the distance, at this point the velocity is this much, they said. Okay, let me consider the ball was at rest on a ground. Let this velocity be initial velocity. U is equal to 0 meter per second, because this is at rest initially. With 0 velocity, it started going up. The moment it reached half the way, its velocity was this much. But again it went up. Okay, so at this point it has reached, but they are asking its displacement, actually height, which is nothing but displacement from here to here. What is the displacement? Okay, say which is the formula? First you calculate this height. This height will be h by 2, no? Yes, so this, let it be the displacement. Okay, let me call it final velocity is there, initial velocity is there. Let me consider h by 2 as displacement. Okay, and let me calculate that first. Okay, and they said g value, acceleration due to gravity, g value they have given, that is 10 meter per second. Say always this direction I will consider as positive. Upward direction is always positive, right? Okay, so here acceleration is nothing but g value, that is 10 meter per second, right? And u value is there 0 meter per second. V value is there. I am calculating this distance first. This displacement I am calculating, that is h by 2 I am calculating. Okay, so for that V value is 10 meter per second. It's going up, all up. U, V, A, all in same direction. So positive sign I have considered. Okay, fine. And now what is the formula you will use here? V square minus U square is equal to 2AS you can use, no? 2AS, this formula you can use. So here V square minus U square by 2A will give you this displacement. Remember, I am just calculating h by 2, which is nothing but s now for time being. Okay, so what is V square? V square is 10 square, right? 10 square minus 0, 2 into A. What is A here? A is 10 meter per second square, 10, right, is equal to displacement. So that is 10 square is 100 divided by 2 tens are 20 is equal to yes. So that is 5 meters is your yes, right? So what is this yes? It is nothing but h by 2, right? So your h by 2 is equal to 5. So what is h? This much is your h. They are asking you to calculate the total height. H is how much? H is equal to 5 into 2, that is equal to 10 meters is your answer. Okay, so how much is the total height? 10 meters. So hope the problem has become clear. So this was the question asked in 2011 NEET examination. Okay, coming to the third question, guys, this is also a much simple question. Just you have to draw a diagram and understand what is given and what you have to calculate. See, a boy is standing at the top of a tower of 20 meters height, drops a stone from there. Okay, so there is a tower. Here there is a boy who is holding a stone. Okay, so he dropped that stone onto a ground. Okay, so what is the height? It is 20 meters. Okay, it is the distance between the boy and the ground. That is the height 20 meters. From there, he is dropping a stone onto a ground. Okay. So, from here, the stone has come here. So, what they are asking you to calculate? What is the velocity with which it hits the ground? So, the moment the ball has hit the ground, what is its velocity? So, that means V they are asking, final velocity they are asking. What must be the initial velocity? The boy is holding the ball. That means the ball is at rest. So, initial velocity is 0 meter per second. Final velocity they are asking. And this is what? Displacement, right? The distance, or this is nothing but the displacement is 20 meters. And what is acceleration? Acceleration they have given g, right? Acceleration is nothing but your g, that is 10 meter per second square. So what is the formula you will use? V square minus u square is equal to 2as. So V square minus u value is 0, 2 into acceleration is 10 into displacement is how much? Displacement is 20, right? So V square is equal to 400. So V is equal to square root of 400. So V is equal to 20 meters. 20 meter per second is your answer. Okay. So everything lies in the diagram, the way you put and the way you understand the question. Okay, so among the given equations of acceleration, select a suitable equation according to a given information, substitute the values with the sign and then calculate. Okay, so that's all about the concept on acceleration. And one more thing I wanted to tell you, all the graphs related to motion chapter will be done in a single video. Okay, so graphs of VT, AT graphs are there, VT graphs are there, XT graphs are there. So about all the graphs, we will come up with one particular video. Okay, so that's all about today's session. Do subscribe our channel to learn the concepts in an easiest way and in a detailed way. Thank you so much.